This is a talk about DevOps, but it's DevOps from a developer's perspective and not from a operations perspective. Because historically, DevOps it came out of the operations community. It actually started, I believe, with a presentation from Flickr, who was talking about their continuous deployment and operations setup. So this is more about how we can play nice with the operations group. So, I'm Mike Crute. In my past, I've been a sysadmin. Now I'm a developer, but I still kind of play both sides of the game. And I'm at mcrute on Twitter. So before we can really talk about DevOps, so this is kind of where we're going with this presentation. We're going to talk about what the heck is this DevOps thing. Some basic common tools that everybody kind of has to have before we can even get into the rest of the techniques. Talking about application deployment and how we can play nicer with those kind of tools. Runtime monitoring, how an operations team can monitor your application and how you can play nicer in that setup. And then debugging the application. When all goes wrong, what tools should be available to both the developers and the operations team. So before we even get into that, what is this DevOps thing? Well, let's talk about developers. The typical perception of a developer from an operations side is these kind of strange guys that are sitting there, tapping on their keyboards, love shiny things. My God, MongoDB. And they're always breaking my servers. Because, come on, we don't give a crap what happens on the ops side of things. But pretty sure that the only reason developers exist is because they can successfully ham-fist features into the system. So let's talk about operations. This is kind of the stereotypical developer's perception of an operations team. They're those guys that pull the levers and push the buttons, and I don't really know what any of that crap does, but good thing they do. They get excited pretty easily, especially during a release. And really, they just say no to everything I want. Seriously, why can't I have MongoDB? It is web scale. But at the end of the day, I'm pretty sure the only reason we keep the ops team around is because they kind of have some way to keep this system stable and fast. So those are kind of the two perceptions of each side from the other side's point of view. So what is this DevOps thing then? Well, on the surface, all it is ops who think like devs and devs who think like ops. Now, think is the key word here, because nobody's saying that you should go be an operations person as a developer, and nobody's saying that the ops people should go in and hack features. But you should at least be able to kind of think like the other side and understand where everything's going and how all the pieces fit together. But at the end of the day, we're still there to enable the business. The operations team just is there to kind of make sure that the business can continue to grow and scale their site, and build and keep the application running. And the devs are there to make sure that we can grow our business by adding features. And the whole point of DevOps is to lower the risk of change by building tools and culture and changing your organization. And that's actually the definition that Flickr gave. My opinion, it's all about communication. We're trying as developers to make sure an operations team can successfully interact with our application a lot easier, so that we waste a lot less time, so that we can continue building features and moving the business forward. And it's useful at any size company. It doesn't matter whether you're the sole developer or you're just a cog in a giant machine. DevOps can kind of help your organization be more successful. So enough of that crap. That's basically what DevOps is. So how can developers be better citizens of an organization and help the ops team out? But before we can go into those techniques, both teams have to have a few basic tools. And these kind of, from here, everything builds. The first one's kind of obvious. It's shared version control. But by shared version control, you actually want to have everything all in one place. Whether it's separate repositories or not, with modern DVCS, you may want to split it up. I worked at a place that just kind of kept everything in a giant Subversion repository. Whatever works, but it's really important that everybody can see the same code. They see the server config, the developers see server configs, and the admins can see the developer's code. And it kind of helps build some kind of shared ownership and everything in the code and in the configuration, because all of a sudden developers now have some insight onto how you're managing their application. And GitHub and Bitbucket are great for this. But again, whatever fits your organization. If you have a giant Subversion repository, rock out. Not to beat a dead horse, testing gets a lot of coverage in conferences, but testing is actually really critical, and testing on all sides of the problem is kind of foundational to this whole DevOps concept. Developers should be writing integration tests for their system so that they can ensure that the code they're writing and the libraries they're working with are playing well together. But then on top of that, your operations team should really have integration tests for the infrastructure. And kind of what I'm thinking here are tests that you can run in a brand new environment to make sure that you can talk to all of your hosts on all the right ports and that services come up, firewall rules are correct. All the stuff that generally gets screwed up when you bring up a new environment should be testable, and it should be very easy for you to roll forward and see what's wrong. And then end-to-end tests for the whole system. This is more of from a developer's point of view. This is your Cucumber tests or your Lettuce tests, or pick your favorite end-to-end testing framework. This is diving all the way down through the application from the very top level and exercising the code. But by doing this, you also end up exercising things like service connections. If you're testing an e-commerce site, you should have an end-to-end test that covers your credit card processor. Because then when you run this suite of tests in a new environment or an existing environment, you can again nail down problems very quickly. Now that you have all this testing though, where does it run? Well, you need an integration a continuous integration server of some sort. And it should be big and visible. Everybody should know what's going on. So in the example of a big company where you have a group that builds billing and a group that builds e-commerce and a group that builds content, everybody should always see what's going on. Whose tests are broken and what's broken where. Because that lets everybody know that what they're working on may or may not work. And you can actually, depending on how clever you want to get, you can use this to trigger your releases. I've seen a lot of stuff built on top of Jenkins that does continuous deployment and other real clever things. And then the last tool you really have to have as kind of a shared resource is integration environments. Some pre-production environment where you can push your code and test it and poke at it and understand what's going on. Because in a lot of applications, I would say most applications, production looks absolutely nothing like your developer's sandboxes. You may be running different queuing configurations, or you may have different middleware setups that are really difficult to reproduce in a development environment. And the staging environment really gives you that place to poke at it. And it's got to look like production. Just setting up another server and firing up your application in a sandbox is not a staging server. It's not really all that useful. This is where you can actually test against everything. Developers have got to be able to deploy there, because this is also where you can test branches. And probably the most controversial one is your dev should have root here. Because a lot of times, this kind of a setup, you may have other higher level servers sitting in front of your application or behind your application, and the only way to poke at some classes of problems is if you have root access. Which also means you have to kind of feel fairly confident that you can rebuild this environment easily, because your devs will screw it up, guaranteed. All right, so that's kind of all the common infrastructure that everyone has to have that underlies the rest of this talk. So let's jump into application deployment. This is the first time outside of your sandbox that your ops team ever deals with your application. And this is probably one of the things that makes them angry the most. So there's really two tools of the operations trade that come into play here: the configuration management systems and the package managers. The configuration management systems are actually what's going to drive all of your underlying setup, your configuration, where files get deployed, and how your configuration gets generated. These are tools like Puppet, Chef, CF Engine, BCFG. Every organization has a different setup here, but one of these will be managing your application at some level. And then the package managers, and these are as varied as anything else. So configuration is probably the first thing we as developers tend to get wrong, because it's actually a far more subtle problem than you'd think. There's the concept of static configuration. This is stuff that is technically configuration, but it doesn't change all that much. A good example of this would be branding, perhaps. If I'm deploying a Django app, I may reconfigure the name in the admin. It's static configuration. It doesn't really change all that much, and a code move, requiring a code move to move this, isn't that big of a deal. But then if you have your staging environment set up, you'll have a per environment set of configuration. This may be enabling and disabling features, or using different sections of the database depending on what you're doing. This is stuff that's generally ops provided, but the way I've seen a lot of people, or a couple of people do this, I guess, is actually letting the developers commit their own environment-specific configuration, and then ops just blasts their config over top of it and ignores that crap. Then on top of that, there's actually a whole other class of service locations. And this is probably the most annoying stuff to find hard-coded in an application, but a lot of stuff that I've seen has this. How do I talk to my queues? How do I talk to my database server? Where is my infrastructure? This should always be provided by operations. And actually, the kind of a clever approach that I like to this is using DNS serve records to do that. It gives you the isolation you want from being able to have different environments by using bind zones, or by having different actual physical locations that way. And you can configure all of your services and ports like that. And because bind doesn't use SQL, it's totally web scale. And then secrets. Secrets exist just because we have to be able to talk to the database on some secure channel. Those should always be managed by ops, never committed in code. And for the most part, we should have ourselves set up to receive our secrets in a secure, common way, and not deal too much with that. The service location and secrets pieces are actually pieces that, in your organization, you should have some common API to access these things. Instead of relying on hard-coded config files, you should be able to call out and ask for your database server, or your queue, or your database password. So commonizing these and letting them be a mystery to your application is really an excellent way to go. Then outside of that, now that we've got the application configured and we can actually have the pieces talk to each other, there's the deployment techniques. If you're doing it by hand, I'm sorry, don't do that. rsync, I'm a little less sorry, but still don't do that. BitTorrent is kind of an interesting way of doing this. If you're Twitter or Facebook, you've probably got some super snazzy way of doing that. But for most people, it's totally overkill, but clever. And then I guess the last one is my favorite. And you can ultimately do this however you want. And actually, your ops team probably has an opinion on how all this stuff works. But using your distribution package manager to actually bundle up your code and install it uses all the existing infrastructure you have, your apt servers, or your Yum repositories, or all the stuff that your operations team already has existing to deploy the rest of the system. May as well tap into that. So scaling your application. One of the things that you should endeavor to do as a developer or as a development team is to make sure that your code is entirely portable. And this isn't always reasonable, but since everybody in here probably codes Python, it is pretty reasonable. The biggest thing that can get you in trouble here really is just syncing out virtual envs and some of the binary packages like the Postgres driver or the MySQL driver. Those kind of things, while we manage them in our sandboxes, we really should be using something like requirements text or some other way to communicate that to the ops team. And all of those things should be very clearly stated somewhere. Nothing sucks more as an ops person than to get an application and start running it and debug it piece by piece and find out, oh, I need this package or that. Pip gives you an awesome way to do that with a requirements.txt file, but ultimately you can find some way to communicate that. So keep your code portable and don't just rely on perhaps binaries or whatever else to get you where you need to go. Also, isolation of services is kind of important. You can go too far on this, but in an example of an e-commerce site, you may have a billing system and a content system and the actual e-commerce platform itself. Each one of those pieces should be broken down in such a way that as the system comes under load and as the operations team needs to scale it, they should be able to peel those pieces out and scale them individually. Binding everything up into one big ball of code makes it exceptionally difficult to scale a system, especially at an obscene hour when you have no developers on hand. And then switches. If you're under heavy load and you have a lot of features, you should understand how those features interact, and you should give your ops team as many switches as possible to shut down pieces and to gracefully degrade your site or application. A company that I worked for actually had this really well nailed down. On a wiki page where the ops team could have access to it, they listed every single switch in the application, what it affected, how it degraded the site, and what it would shift load off of. So if the database caught fire on their biggest day, they could go through and say, oh, database flags, I can switch this off and start just shutting down bits of the site without completely destroying the experience or completely tipping over their servers. The thing they got totally wrong is they had like 17 different ways to do that. So the ops team had to maintain a whole bunch of initial crap code, and every developer who got in there created a new way. So don't do that. Gargoyle is a application that the Discus guys have open sourced, and I would highly recommend taking a look at that for a feature flipper kind of setup. It gives you the client on the backside for actually flipping your features, and it also gives you a web interface so you can see where your features are flipped and let an ops team do that easily. And that's kind of the basics of things that we can do to make the application deployment process less annoying. Package your code in a way that's sane and that fits with your ops team. Figure out how to scale that and make that portable, or at least give your ops team the tools to poke at it, and start to peel apart your services a little bit more so that the application can be scaled in some reasonable fashion. So after we've deployed everything, this is where really most of the ops team's life lives, is in runtime monitoring of your application. And this is usually painful because of the way most applications are built. So there's a couple tools, actually quite a lot of tools that exist for managing your application. This is just a summary view of the ones I use on a regular basis. For every single line, there's at least a dozen of these. So Splunk aggregates and searches logs. Nagios is used for real-time monitoring of your system. There's a whole slew of tools for statistics collection and graphing and actually visually understanding your system. And I guess those two go together. And the last one, I'm not going to talk too much about this, but you should have some scriptable interfaces to your website so that, or to your application in general, so that an ops team can automate poking at things. But one of the first things that an ops team is going to look at is logging. And you want to break down your logging. The Python standard library logger makes this really excellent. Break down your logging by subsystems. Don't just log everything to the root logger, because when you're taking on a lot of traffic, it's almost impossible to find anything. Use your levels correctly. I knew a guy who logged everything at error, even if he was just logging database queries. Those log files suck to try and read. grep is king. If you can't grep your log files, don't bother logging. And if you want to be the absolute hero, if you can find some way to actually trace your session through your log files, through some session token or some other unique identifier, so that you can actually roll up a whole set of logs for a user's session, that is probably the holy grail of logging. And I don't really know anybody who does that. So a couple of people in the room are going to kind of get this. PrettyLog. PrettyLog was a library written at a previous employer that was the exact opposite of its name. PrettyLog looked a bit like that. That's a single log entry. So what is it? Well, it's a debug log written here for the billing system with, the error occurred on this line of code on that PID. Oh, and it happens to be this module. What the hell is this? Oh, that just happens to be encrypted data that we couldn't log because it's a customer's credit card number. Don't worry about it. So what does that, what do you ultimately end up when you have something called PrettyLog? A whole lot of that. Everybody wrote a tool to make this thing suck less. And basically all they were things to rewrite these logs into like a standard Python log format. Don't be PrettyLog. Okay, so on top of logging, then there's exception tracking, which is kind of another step beyond that. Anytime an exception occurs, you should track it on your site, no matter what it is. And you should have some way to plot this on a heat map kind of thing, so that you can see what's actually going wrong in your system. The same company that did PrettyLog had a really nice way of tracking exceptions. They had a traceback monitor that you could go and look at after a code release and see if you really horked the site up, because the site would actually start to turn black. It was pretty fancy. It would actually go from yellow to red to black, and you could see very quickly that you broke the site. That was built a long time ago. The Discus guys, again, have released another tool called Sentry. Actually, no, this is not Discus, but they have a add-on to this. But Sentry is basically that, open source and available for anybody to use. Or if you want to be all Web 2.0, there's New Relic, which actually is cool. It gives you a lot more detail than just exceptions, but it can give you some very fine-grained detail about what's blowing up on your site. And whatever you do, make sure there's some kind of bug tracker integration with whatever's tracking your exceptions. Because a lot of times a exception that tends to take off needs more input than just you as a developer. You need the development team to fix the bug. You need the ops team to deploy it. You may need a business owner to kind of come in and clarify some functionality. So you need to be able to take that exception and all of its related rich detail straight into your bug tracker. That'll make your life a lot easier. So on top of that, statistics are kind of a nice to have, but they can also tell you if you're totally on fire. And you kind of want to know that. So provide as much as you can, and this the statistics is kind of hard to talk about because it's very, very application specific. If you're building a billing system, you need to know how many transactions you're taking, how much money you're making. If you're building a mail queuing system, you need to know mail queue information. But provide whatever makes sense in your application and expose it in a sane way so that an ops team can get at it. Ganglia is a nice tool for something like this because it gives you graphs and you can see your entire cluster performance. And don't worry about logging everything. I mean, you don't have to deal with all the statistics, but what makes sense in your environment. So Nagios, probably the most misunderstood tool that on a development side. It's really for runtime monitoring of your application. And the typical use case is simple ping tests or HTTP checks. Just poking at the top level of your application to see if everything's okay. But that's only the simplest use case for Nagios. Nagios can go a lot deeper, and this is where developers should kind of get involved in working with your ops team. You can do passive checks, which is basically your application can go to the Nagios server and say, hey, I'm about to do this thing, and drop a passive check over on the Nagios side. Nagios will then kind of monitor that and wait for some confirmation that everything happened and everything is good, and then it won't warn about it. I saw a really strange system that did something like this, but completely misunderstood Nagios. Every time the application fired up an event, it would send an email off to the Nagios server, and the Nagios server would start monitoring stuff. And then if the finish email didn't come back in, then the Nagios server would freak out, and there was no way to silence the Nagios server without blowing away a lot of useful data. And if email ever went down, you were completely screwed. But never mind. I guess I'm not really explaining that well. But in any case, your application should be able to reach out and touch a Nagios server with some information and have it monitor you. And you can also do custom active checks. These are actually the polling checks that a Nagios server will do on you. So if there's some way that you can check your underlying dependencies and make sure everything's happy, you can have a custom Nagios check that then looks at that and will alert the ops team if there's a problem. So these are two things that we as developers should really be providing to the ops team to manage or to monitor our applications a lot more effectively. And an ops team will figure out how to make these things happen. But if your application is designed from the get-go to be easy to monitor, your ops team will love you. And the last piece kind of ties in with the statistics. SNMP is how your ops team already gathers box data, CPU information, disk space usage. Tap into that. It's pretty standard. Everybody runs it. Everybody uses it. You can provide individual stats, such as counters or whatever, or you can provide groups of stats if you have more rich data to describe. It works nicely with Cacti for graphing and MRTG for graphing and all these other visualization tools. And NetSNMP is easy to extend, super easy actually. You can write a Python script or a shell script that just gives back a number on standard out and tell your SNMP server to execute it, and it'll feed the data back upstream to whatever's collecting that data. Managing on top of that, then you have to be able to manage your errors, and this kind of ties in with the exception managing. Repetitive errors are death. Nobody likes to get the call in the middle of the night that something's down and all they can do is watch errors pour in and their phone keeps ringing. So fix your errors as they come in. Sometimes you can't fix them without moving code. It happens. But make sure that you have some way to silence those errors temporarily. If your notification system continues to page you all night for the same error that you can't fix without a code move, you're just going to walk into work sleep deprived and pretty angry. But continue to log those silenced errors so that when you do get in the next morning, you can actually debug something. So that's kind of a lot of the pieces of runtime monitoring. The things that are probably the most important are tap into Nagios, make sure that your application is easy to monitor and provide some facility for that, and tap into SNMP. Tracking statistics as it makes sense in your project, in your application, will make it a lot easier to determine if you're on fire later. So when everything goes wrong, what tools do you need to have available? Well, there's some tools on the ops side that are pretty rudimentary. grep MSSH for touching a lot of hosts and pulling down extra log files. Splunk for digging through those log files if you're actually aggregating them at a syslog level. Filters. Filters, I guess, would be kind of like the deep pretty log thing. How do we weed through all this data that's coming in these log files? And these can be used actually on the end of tail or something like that to give you a little bit more real-time view of the data before it gets to Splunk. And management interfaces at a high user level. So logging again. you should have some, if you're doing your logging correctly, you should have some way for the ops team to configure what level the logging happens on, whether it's debug level or warning level, or there should be some way for them to dial that knob up, and then deploy that at a detail level. So one company was actually had, I think it was about 10% of their production traffic running on detail boxes. So when something caught fire, you could actually go down there and start digging through like what database queries got run and why am I on fire. So a console. If you're using modern web frameworks like Django, the console's already built in, but you should have one, and it should tee up an entire application environment for you. You should be ready to start poking at the application, and you should be able to run this as a developer or an ops person in production. Probably don't want your ops people running it, but they should be able to. The same with an interactive database shell. Both of those are going to help you debug things, and you should provide the scripts to fire these things up and get them ready with all your application configuration and environment preloaded, so that when you do find the box in production that's somehow different than everything else, you can jump in and figure out what's going on. And all that stuff should have read-write access to the database, because once you get into production and you've found that one box that is different, if you can't change anything, what's the point? I'm going to run through this. So script everything. If you come into issues that are recurring, write a script, document it, commit it, so that your support team can run it. You don't want to be up every night fixing that one issue. And anything you script, you can then use later to maybe test that you fixed something. So script everything. Make sure you commit them. Make sure other people know how to run them. Provide management interfaces to your users. If a user can't solve their problem and can't see what's going on, then you're going to get called as a developer, or your ops team's going to get called, who's going to call you and ask you to fix things. If you just give users the details they need and the interfaces to fix their own problems, then you can kind of head off a whole lot of this. But don't overwhelm them with details. I mean, don't be giving your end user stack traces. That's not terribly helpful. And anything you can fix through a management interface obviously shouldn't need a code move. I say this because a couple of systems, actually the only way you could interact with a management interface was to move code and then push a button to make it happen in the management interface. Totally not useful. And so that's kind of a couple of tools that we can provide as developers to an ops team, or even for ourselves, that then can help us debug and solve problems a lot faster. And that's it. Questions?
What would you use for the secrets part? You talked about earlier. Can you repeat the question?
Yeah. So the question was, what would you use for the secrets part? It depends on your environment. I know Heroku has a way to inject that data into your environment. I tend to just use a set of reasonably locked down files and a Python API to poke at them. It's just ini files. I don't know off the top of my head of any good solutions to do that are pre-baked. It's kind of roll your own. Anything else?